Welcome to MrCScience.com's video on ionic versus covalent molecules. We're getting into actual chemistry here, so what we have to do is be able to deal with how we name these different molecules so we all know what we're talking about. Ionic versus covalent, we will also later in the class learn that there's more than just naming conventions that's the difference. It's also how they share electrons. But let's move on. Let's start with chemical formulas. This one you're familiar with, H2O, everyone knows that as water. And other two, CH4, methane, and C6H12O6, glucose. What does this mean? Might be apparent to you, but let's just go through it. So H2O, what does that mean? It means this number 2 here means we have two hydrogens. The lack of a number here doesn't mean 0, it means 1. We have one oxygen. So water, H2O, is made up of two hydrogens and one oxygen. How about methane, the next one? The lack of a number here before the carbon means one carbon, and the 4 after the H means four hydrogens. Pretty simple, right? So this one should be simple. Take a guess. This one spells it out pretty simple for you. 6 after the C means 6 carbons. 12 after the H means 12 hydrogens, and the 6 after the O means 6 oxygens. Pretty straightforward. Everything is sub. If you ever see a number above, it has a different meaning. But when we're writing out chemical formulas, it's how we write it, just the number of each atom in the compound. So let's talk about ionic compounds. What is an ionic compound? Well, your book says an ionic compound contains at least one metal and one nonmetal. Well, what does that mean? Well, let's go back to our periodic table of elements. Remember this jagged line right here between the red and the green and the yellow here? Well, that separates the metals from the nonmetals. So in here, the metals are all red, and hydrogen, we'll talk about later why it's over here, is a nonmetal as well. So any of these nonmetals, so at least one metal, one of these yellow, green, blue, combined with at least one of the reds, will make up an ionic compound. Now again, ionic compounds also share their electrons differently, but we'll check that out later in the course. So a covalent compound contains only nonmetals, so only the red. Only everything to the right of this jagged line and hydrogen are covalent molecules, and again, they share their electrons differently. Let's talk about how we name these. Okay, I've got 4 ionic compounds here on the left. Our sodium and chlorine, our beryllium and oxygen, our cesium and carbon, and our barium and fluorine. So let's talk about how to name these. You'll need your book for this. Grab your book. If you don't have it, stop the video, grab it. And we're going to turn to page 67. Okay, so our naming conventions, it says at the top of page 67, start with the name of the first atom of the molecule. Well, this one is sodium. So we're going to start with sodium. And if you look up O in our periodic table of elements, you'll find its name is oxygen. If you look up oxygen in your IOD table, you'll find that it is oxide. Our next one, cesium carbide. With the cesium and the carbide, we ignore the 4 for right now. Last one, Ba, is barium, and the last one is, so that's right, barium fluoride. Pretty straightforward. Ionic compounds that we deal with will only have 2 elements in it. So there are other things that break this, but we won't deal with those in this course. Okay, so let's deal with covalent compounds. Now here's 4 covalent compounds I've listed for you. If you look up these compounds in your periodic table, you'll notice that they are all non-metals, so there are no metals involved in covalent compounds. So let's deal with the first one, CO2. You recognize that as carbon dioxide. So how do we name that? Let's start by using the regular ionic naming convention. So first we name the first atom carbon. Then we name the second atom oxygen, which we look up on our table as oxide, so carbon oxide. But now we deal with this number here. That 2 tells us there are 2 oxygens. So if you look at the bottom of page 67, there's prefixes for naming covalent compounds. So if you look up 2, 2 means di. So what we're going to do is we're going to put di in front of oxide. And we get its name, carbon dioxide. So now let's look at our next one. If we were just strictly naming these as ionic, this would be carbon oxide and this would be carbon dioxide, even though they're different molecules with different properties. So that's where covalents get a little more complex. So we're going to do the same thing we did with the other one. We're going to list our carbon and our oxide. So carbon oxide, but this time we don't have any numbers. But we have our, I should have mentioned this first one, we have no number here. So no number means 1, right? So 1 means mono. Now when the first element is a single, we don't say monocarbon, so we didn't have monocarbon dioxide. You drop the mono if it's the first atom and it's only 1. If we had dicarbon dioxide, then we would write it. So we got monocarbon, so drop the mono, and monoxide. Now we don't want monoxide. When you have a vowel beginning, then you shorten it to monoxide, so carbon monoxide. So one's a gas you breathe out, you can breathe in, it's good for plants. The other one's a gas you breathe in and it can poison you, so it can cause problems. So same atoms, carbon and oxygen, just different amounts, and we get 2 different molecules named differently. So this one gets a little more complex. We've got 2 carbons and we got 6 hydrogens. So let's start with our ionic naming convention. So the first one is carbon, and the second one, looking up hydrogen in our iod table, we see that it's hydride. So carbon hydride. Now we got to deal with these numbers. First one, we've got 2 carbons. Look up 2 in your table and you see that it's di. So we have dicarbon hydride, but we've got that 6 there for the hydrogens. So let's look up 6 in our table. And you got hexa, so we've got dicarbon hexahydride. This is actually an organic molecule which has completely different naming conventions. It'll be known as ethane later if you get into organic chemistry, or we'll talk about it a little bit further in the class. So let's do our last one. So start with the naming convention. Go ahead and do this one on your own, then I'll give you the answer and we'll talk about it. So start with the naming convention, look up your atoms in your periodic table of elements, and then add your number of atoms. You get sulfur dichloride. So that should work out for you. Naming conventions aren't too difficult. The covalent's a little more difficult. Most of your covalents will end up with just mono in front, so no mono, just the atom itself. Your book will not give you more than 2 atoms because you get a little more complex when you get into that. And one thing your book doesn't mention, but when you're writing out chemical formulas, you should always put, not always, but a good rule of thumb for you right now is if you're unsure, put the one with less amount of atoms in front of the other one. So like our sulfur chloride, or sulfur dichloride, we had 2 chlorines, 1 sulfur. The sulfur went first. There are obvious exceptions to this rule that we don't get into too much, especially when we do things like polyatomic ions and fun stuff like that we'll do later. But if you have any questions on this, as usual, drop me a line at mrc@mrcscience.com. Thank you.